135, asteroid collision. So we are giving an array asteroids. It's gonna be the positive and the negative integers, because we can see from here asteroids I not equal to 0. So this is also true because for the asteroid, this positive just means a direction. So this direction just means to the right, and this negative value just means there's a direction for the asteroid to the left, and this value is just the weight of the asteroid. So for example, if this is a 10 to the right and -5 to the left, so there will be a collision of the two asteroids. So this 10 will be collided with this -5, and the final result would be 10, and the direction would be the same. So this is the definition of the problem. Yeah, so for each asteroid, the absolute value represents its size, and the psi represents its direction. So we know about the direction. If it is positive, right. Negative, the direction is left. So we need to find out the state of the asteroids after all collisions. So for this example, after all collisions, this 10 and -5 is going to be 10. So the final array would be 5 and 10. And this 8 and -8. So if they are equal, so it's going to be nothing inside, so it would be an empty array. So if both are the same size, both will be explode. Two asteroids moving in the same direction will never meet. So for example, this 5 and 10 is in the same direction, it will never meet. So let's check the final example. So this 2 and -5 is going to be a -5. So this -5 with 10 is going to be a 10. So the final array would be 10. So let's try to solve the problem. According to the problem, we just need to return an array. So if there is a collide, it's going to be merged. So this is a typical stack problem. So we can define a stack to solve the problem. Why? Because if there is a collision, it's going to always be the final two values of the stack. I mean the last value and the second last value of the stack, if there is a collision. Otherwise, everything will be just inside of the stack. So we're gonna check the asteroid. So for A in asteroids, so we're gonna put it inside of the stack first. Stack.append with the asteroid. Now we are going to have a while check. So while the length of the stack, we have to check if the stack the length is more than 1. It means at least we have two asteroids, and then we're gonna check if there's a collide or not, collision or not. So for example, for this example, we're gonna put 5, 10, and -5 inside of the stack. So if the length is more than 2, currently the length is 3, so we're gonna check the last two values. Yeah. If it is more than 1 and the stack -1, I mean the last value is less than 0, and the second last value, -2, is more than 0. Then there must be a collision. So we're gonna check the collision. So we're gonna pop out the two values, P1 and P2, gonna be the stack.pop and the stack.pop. So we're gonna pop the two sleeves, and then we're gonna check if P1 plus P2, because they are not in the same direction. So P1 plus P2 equal to 0. So we're gonna do nothing. So we're gonna have a continue. Else we're gonna record the result. So the result would be P1 if absolute of P1 is more than P2. Otherwise, the result would be P2. So finally, we're gonna put the result inside the stack. Yeah. And finally, we just need to return the stack. Let's just simulate one example. So for this example, we're going to put 5, 10, and -5 inside the stack. So we're going to put 5, and 10, and -5 inside the stack. Then we're going to check the last two values. So the first value and P1, and the second value P2. Yeah, so this is P1, and let me use another color. And this is gonna be the P2. So P1 and P2 gonna put inside of the stack, and then this is P1, and then we're gonna pop it out. So if they are equal, we're gonna continue. Otherwise, so this popped out and this popped out, we're gonna check the result. So the result would be 10 because the absolute of 10 is bigger than absolute of -5. So we're gonna have the P2. So the stack would append the P2. So the final array would be 5 and 10. So this is just a simulation. So this is why stack works. Now let me submit it to check if it works. As you can see, it works and it's really fast. And the time complexity is just O(n). N is the length of the asteroids. Let's check the asteroids. So the length is 10 to the power of 4. That is why it is so fast. Thank you for watching. See you next time.